Hello, today we are going to discuss about the inductive thickness transducer. It is based on the principle of inductance. We are going to use it for the measurement of thickness of materials. Now, what is an inductive transducer? The inductive transducer are those in which the self-inductance or mutual inductance M varies due to the variation of quantity under measurement. They are mainly used for measurement of thickness, displacement, etc. In the case, in this case, we are going to measure the thickness when there will be a change in material whose thickness we are measuring. There will be change in self-inductance or mutual inductance. That is, the inductance thickness transducer is basically convert the change in thickness into change in inductance. The output will be inductance and input will be the thickness. They are basically used for the measurement of thickness and displacement. Now, for industries, the inductive transducer are used for measuring the thickness of rolled sheet or mass produced by the object. There are various kinds of materials. The thickness of the test piece or test materials plays a huge role. We have to ensure that it is on the right length, breadth and height. In that case, any sort of inductive transducer comes to play. That is, the materials whose thickness is to be measured is called test sheet. It can be mainly three types. First one is magnetic and conducting, that is example is iron or steel, and second one is non-magnetic or conducting, that is aluminium, and third one is non-magnetic and non-conductive material, that is bakelite. That is, the materials whose thickness is to be measured is called test sheet, and it can be mainly of three types. So there are some pre-requirements of test materials has to be satisfied. That is, first one is permeability. The ability of the materials to be magnified is called permeability and it is denoted by mu. And second one is resistivity. The ability of materials to flow the current is called resistivity and it is denoted by rho. It should not be fluctuate or it should not be changed. The only thickness which is measured by the inductive is about 25 microM to 2.5 mm is possible. And the accuracy of inductive thickness transducer is 2 to 5%. Now coming to the design of inductive transducer. The inductive transducer consists of mainly following parts. The first one is magnetic yoke or the frame of the inductance transducer. And second one is primary and secondary winding. That is, we are providing our excitation voltage at primary winding and output is taken across secondary winding. And third one is test material. That is, the materials whose thickness is to be measured is called test material. And fourth one is excitation voltage that we are providing across primary winding. And the test material is the part of magnetic circuit and complete the magnetic path. So that there is a current flow in the circuit and the test material complete the circuit continuity. And there are mainly two types of arrangement. And this first arrangement is C-shaped yoke. Here primary winding and secondary winding are connected across it. Here the NP is called primary winding turns and NS is called number of turns of secondary coil. And we are providing our excitation voltage EA across primary winding NP and output is taken across secondary winding V0. And here the test piece is connected. And whenever the test piece is move, at that time the air gap also changes. And due to that movement, the flux across that yoke is changed, and at that time the inductance also change. And we can get the output as per the changing inductance. And the second arrangement is just like that, that is M-shaped yoke. And on the center is connected, the primary winding and secondary winding is connected across center. And here we are providing our excitation voltage and we are getting output voltage here. And the test material is just like this. And whenever the test material is moved, the air gaps also moves and the flux change across it. At that time the inductance also change and we can get output voltage corresponding to the thickness. Now the relationship between the inductance of the coil L and T. That is, we already know that in self-inductance L is equal to N2 into mu 0 mu r dt divided by L. That is, N is equal to number of turns of the coil and mu 0 is the absolute permeability and mu r is the relative permeability. And T is the thickness of the test plate and B is the breadth of the test plates and L is the length of the test plate. Now we already know that the number of turns, absolute permeability and relative permeability, these are all constant. And the first primary condition is we have to keep that breadth and length of the test material is to be constant. At that time we can know that the inductance is directly proportional to the T, and we know that all other parameters are constant. That is, both B and L already known, the others are constant, and at that time L is directly proportional to the thickness. Once the self-inductance is known, it can be converted into the corresponding voltage or current by using the signal conditioning circuit as AC bridges, and just like our Wheatstone bridge. Here the self-inductance is directly proportional to the thickness of the test materials when all the parameters are already known. And these are the basic concept of inductive thickness transducer. And it consists of mainly 4 parts. First part is magnetic yoke, and second part is primary and secondary winding, and third one is test material, and fourth one is excitation voltage. And we have mainly 2 types of arrangement, arrangement 1 and arrangement 2. Arrangement consists of C-shaped yoke and arrangement 2 consists of a M-shaped yoke. And here primary winding and secondary windings are connected across the C-shaped yoke, and here the center core is connected at both the primary winding and secondary winding. Now the relationship between inductance of the coil and TR, L is equal to N2 into mu 0 mu r into Bt by L, and L is directly proportional to thickness when all other terms are constant. And these are the main factors of inductive thickness transducer. Thus we can measure the thickness by varying the inductance of the coil. Thank you.